Hello everyone. Today we would be doing lab 3, which is exploration with the slope of tangents. So before we start, kindly make sure that you read all of these and try to have your work submitted just the way it is asked to submit. So this lab is divided into two sections, which is section 1 and section 2, and section 1 has further two sections. I have already created a MATLAB file for this, and I'm going to explain it from there. Try to read all the instructions and follow the same even for your assignments. Okay, let's get started. So section 1, this lab is all about tangent line of a function. It can be any function, but to be precise, in this lab we will be looking at cosine function. So we'll plot a function and find tangent line for that. So we are specifically looking at a point x is equal to 2 or c is equal to 2. I'll let you know what that is. So for the first section, we would be fixing a point and we would be plotting a tangent line at that point. When I say that point, x is equal to 2. So the first subsection of the first section 1 is eyeballing a tangent line, which is very easy, and this can be done on a piece of paper as well. So the function is cosine of x. So as usual, define a variable, then the function, then plot the function. As soon as you plot the function, you see this blue line. That blue line is your cosine graph, cosine curve. Now what I'm going to do is, we need to plot a tangent line at x is equal to 2. So that means you have to follow this straight. You have to have a straight line corresponding to this graph, to this curve. So open the window and then try to zoom in as much as possible until you see a straight line. Of course, tangent is a straight line. So try to zoom in at point 2. Make sure that you have point 2. Then try to have 2 points. So I'm going to fix one point there, the other point right there. So I'm going to call that point where you see x and y as x1 and y1, the other point as x2 and y2. So I have those points typed them down there. So I plotted the function, I got the intercepts, then I need to have slope. So where m is my slope, the equation for slope is y2 minus y1 divided by x2 minus x1. Of course, you need to have a slope to plot a tangent line. Then I have a tangent equation. You don't see this tangent equation in your lab manual, so I have them made separate, and that makes it easy. So tangent of x is equal to y1 plus m times x minus x1. You already know what y1 is. You already know what x1 is. Now we need to plot the tangent line by plugging in all the x values from 0 to 4. So when you plug all the x values from 0 to 4 in that equation, of course tangent is a function of x. So when you plug it and plot it, easy plot tangent of x from 0 to 4, you see the straight line, and at x is equal to 2, these two lines are meeting. That is the intention of our problem, right? So we plotted a tangent line at x is equal to 2. So I have a curve and I have a tangent. So that is very simple, and you see this theoretically. Now the next section is systematic approach to approximating tangent lines. So what we did above is we picked up points and then we solved it line by line. But here we are reducing our work. So in the process of reducing our work, we have to change quite a few things. So what I'm going to do here is, I'm going to call x1, y1 as c and f of c, right? So x1 is the domain. So let's say x1 is 0.5. Now when I plug 0.5 into my f of x equation, I see f of 0.5 somewhere there, right? So that is the range. You saw that in the last class. Similarly, x2 and y2. Now I'm going to say x2 as 2.5, and the distance from x1 and x2 is h. So the distance from x1 and x2 is h, right? So my c is x1, my f of c is y1. Now my c plus h, my c is x1, right? x1 plus h, that is the distance from x1 and x2, will take you to x2. Now that means my x2 would be c plus h. Now when I plug c plus h to my f of x equation, it would take me to f of c plus h, that is the range. So that's what I've done there. Now I have something new, which is difference quotient, that is as similar to the slope. Now let's go and see what it is. Now remember, now I have three unknown variables, that is c, h and x, where c is x1, h is difference between x1 and x2, and x as usual is an unknown variable. My function remains the same, that is cosine of x. Now my slope is no more called m, now it's called difference coefficient. It's a function of two variables, c and h. Now let's look at what is f of c plus h. Now f of c plus h is y2, we have y2. Then f of c, what is f of c? F of c is y1, which is y1. So y2 minus y1. The entire numerator is divided by h, where h is x2 minus x1. Do you see the difference now? My slope here was y2 minus y1 over x2 minus x1 is now converted to a systematic approach with functions all in place. Similarly, my secant line, which is actually the tangent line, where y1. So my y1 here is f of c. I have f of c. Now the slope is dq of c comma h times x minus x1. Now my x remains the same. My x1 is going to become c. That is what I have. See that? I'm just changing everything to functions. Okay, that is so far so good. The next thing what we have to see is, now we cannot simply assume some h values, right? Now if you see closely, we chose points, but here we are choosing x1 and x2. So we cannot simply choose x1 and x2 randomly. So that is why we have to see the h value, that is the difference from x1 and x2, has to be such that we have a suitable tangent or a very good tangent at the end. So that's what we are trying to see here. Now my x is still 2, that is because we are focusing at x is equal to 2, and we are checking for all the values of h in our slope equation. So for h is equal to negative 0.1, I have slope as 0.9285, and at h is equal to 0.1, I have negative 0.88, and h is equal to negative 0.001, I have negative 0.909, and so on and so forth. It goes on and on. So in order to further check, take h is equal to 0. That means you have no difference between x1 and x2. So that means you are limiting h value for a slope equation. And you have seen this code VBA to just make sure that you have everything in decimals, and you are limiting your slope equation for the values of h to 0. You're tending h tending to 0 for your slope equation, and you're limiting your answer to four significant digits. So you have negative 0.9093, which is actually this. At h is equal to 0.001 or h is equal to 0.0001, you have the same answer. So that means if you reduce the h value, you have a very good slope, and you see a very good tangent at the end. So that is what you see. When h is equal to 0 or as minimum as possible, you have a very good tangent. Similarly, you are also trying to limit secant line. So as you limit h tending to 0, you have that equation. And remember, secant line is a function of three variables, c, h and x, where x is an unknown variable, where if you try to plot secant line, you are plotting it for all the values of x, just like we did tangent line was simply a function of x. So secant line is a function of three variables, which is c, h and x, where h is the difference between x1 and x2. Okay, so from this section we came to know that the as least as h as possible, we have a very good tangent. So that's what I made a comment, so try to read them down again and again if you don't get it. So section 2 is putting it all together, putting whatever we have learned together. So here I am taking two functions to just compare slopes of one function with the other. So my first function is f of x, which is cosine of x, that is okay. So we are trying to investigate the slope of tangent to a single x value. So if you look at this, we fixed a point at which a tangent line has to be plotted, right? We fixed x is equal to 2. We just have one tangent at x is equal to 2. Now on the second section, we are not fixing x value. Instead, we are fixing h value. What is h value? H value is the distance theorem between x1 and x2. So on the first section, we fixed x value. On the second section, we are fixing h value. Okay, that makes it clear. Now here, see that if you closely see that dq was c comma h, so we had c is equal to 2, right? Now here dq is not c comma h, it is x comma h. So we are trying to find all the slope values for different values of h for a fixed h. Okay, so now my h is 0.5. So I'm plotting the function f of x, which is cosine of x. I'm holding it on. Then I'm plotting the slope. So when I plot it, I have this graph. Now try to figure out which one is cosine graph and which one is the slope graph. I'm going to give it to you. Just look at the graph and you can even easily guess it. So try to find what is cosine of 0. So cosine of 0 is 1. So my blue curve is the cosine function, and the red curve is my slope function. So the slope is following the cosine graph. Do you see that? So at h is equal to 0.5, you have that slope. So try to do the same thing by varying your h values as 0.5 and 0.25, and you see, let's plug it and see. Your slope should match the cosine function. See that? I mean, if you have 0.025, you will see the slope matching the function. Okay, then let's choose another function. Did you see that it got shifted? So let's choose another function, which is g of x as sine of x. Let's plot all of them together at h is equal to 1. Now at h is equal to 1, you see the difference between sine of x and cosine of x is the slope. So try to figure out which curve is sine of x and which curve is cosine and the slope. So all of it, what we have seen is by fixing h value to as least as possible, you see the slope of the function or the tangent is actually meeting with the slope of the graph, the curve of the graph. So that's it for the class activity. In order to recap, this is what I can say. The first section, you're fixing x value and you're trying to plot the tangent by varying the h value. Now in the second section, you are actually fixing the h value and you're trying to plot the slope and the secant line or tangent line by varying the h value, x value, that is c value. So even on the assignment, you see these kind of questions, so try to relate them, and it is as simple as this. You just have to change very few things. That when I say very few things, it is just the data. You just have to change the data and rest of the procedure remains the same. So I absolutely recommend all of you to read all the comments that I made, all the explanation that I gave you, and that's going to help you to solve the assignment and the class activity. So that's it for lab 3. See you in lab 4. Thank you.